Space. It intrigues us. It draws us. Since the dawn of humankind, it's been the final frontier of travel and exploration. From the early humans who looked up into the night sky to the moon landing in 1969. However, there's a darker side of our obsession that rarely sees the light of day. Because the road to each technological leap contains not only speed bumps, but tragedies. And even in modern times, with the most advanced technology from the most wealthy of owners, we've seen them occur.
3, 2, 1, release.
Fire. Welcome to space.
To all you kids down there, I was once a child with a dream, looking up to the stars. Now I'm an adult in a spaceship with lots of other wonderful adults looking down to our beautiful, beautiful Earth.
In September 2004, co-founder of Virgin Atlantic, Richard Branson, announced the most ambitious project of his entrepreneurial career. It was called Virgin Galactic, and for the first time ever, its goal was to take tourists to space. If they could fork up the hefty price of $200,000 for a seat. Ambitious nonetheless, the idea of a non-government organisation flying to space had already been developing for years. At around the same time, a contest known as the X Prize was available to the first NGO which built a reusable spacecraft and reached the Kármán line twice within a 2-week span. The company that would go on to win the prize was called Scaled Composites. Their efforts attracted the attention of Branson, who sponsored their attempts late in 2004, with the announcement of Virgin Galactic coming just a week before Scaled secured the X Prize. The very next year, in 2005, Branson and Scaled formalised their relationship into the Spaceship company. It would work to develop Scaled's original Spaceship 1, which only had room for 3 people on board, into the first ever spacecraft designed purely for joy flights. Spaceship 2 would have room for 6 passengers and 2 pilots. Carried up to altitude by a specially designed aeroplane called White Knight 2, the design mission involved the spaceship being released at 50,000 feet, gliding for a few moments, and then firing its rocket motor, producing 61,000 pounds of thrust, accelerating the spacecraft to supersonic speeds as it pitched up to a near vertical attitude. The apogee, or maximum altitude of the maneuver, would be 360,000 feet. Re-entry into the Earth's atmosphere would then occur, and the spacecraft would transform back into an aeroplane, gliding and landing at Scaled Composites base in the Californian desert. As with all ambitious projects in space, there were several challenges to overcome as Scaled, who would oversee the design side of the project, put Spaceship 2 into development. The first obstacle was the less than trivial task of preventing it from burning up on re-entry. You see, when spacecraft re-enter the Earth's atmosphere, they must survive extreme conditions. Their immense speed, combined with collisions with atmospheric particles, generates temperatures up to 1600 degrees Celsius. If the heat can't be reflected away, the spacecraft can burn up. The Space Shuttle, developed in the 1970s, employed reusable insulation across its entire body, as well as reinforced carbon tiles on its nose and wing leading edges, just to cope with the conditions on re-entry. The plan for Spaceship 2 was to minimize the extreme heat altogether. They created a mechanism known as a feathering system, where the stabilizer would pivot from its normal horizontal position up to an angle of 60 degrees, providing crucial drag and slowing down Spaceship 2 during re-entry, spreading manageable heat loads across the entire spacecraft. The construction of the first Spaceship 2 prototype began in 2008, and Branson, keen to build the hype of the project, stated that the first commercial flight was just 18 months away, a completely unrealistic expectation at this stage of the project, but one that would be reaffirmed many a time through the development and test process. By 2014 though, real momentum was beginning to occur. It was Friday, October 31st, 2014. Today's flight is the culmination of months of planning, including flight crew training, permits from the FAA, and the design of emergency procedures, not to mention the years of engineering that have gone into Spaceship 2 by this point. It'll involve a 38-second burn of the rocket engine, the longest so far. Once released by White Knight 2 at a height of 46,400 feet, and gliding for just a few moments, the rocket engine will propel the aircraft towards space, before it coasts down from the apogee with the feather system deployed, providing the crucial drag to stop it getting too hot. The feather system is so important to the safety of the spaceship on re-entry that it needs to be checked in flight before it's required at the critical time. As the rocket accelerates past the speed of sound, the pilots will briefly unlock the hooks of the feather system, ensuring it's operating normally without it actually deploying. The test must be done by Mach 1.8, or the risk will be too high to continue the flight with the feathering system potentially not working. However, the test also can't occur too early. During the transonic phase, between Mach 0.9 and Mach 1.1, significant upwards forces are generated on the tail section. If the hooks are unlocked at this point, an uncommanded feather can occur, which during the acceleration period could be catastrophic to the structural integrity of Spaceship 2. So, with little automation available to help them, a critical part of the sequence for the pilots is to cycle the locks of the feather system before Mach 1.8 or the flight will be aborted, but after Mach 1.4, or the consequences could be catastrophic. This will be a period of just a few seconds. Up the front of the spacecraft though are an experienced crew. Pete Siebold is 43 years old with 2,980 flight hours. He's been a regular test pilot with the company, while also working as Scale's Director of Flight Operations, developing the simulator, avionics, and ground control systems for the program. His co-pilot, Michael Ausbury, also possesses a command rating on Spaceship 2. He's 39 with 2,154 hours. Initially hired as an engineer for Scaled in 2000, he transitioned to the Spaceship 2 program in 2010, and has piloted the spaceship 8 times over the last 4 years. In fact, out of the 30 gliding and 3 powered flights so far, one of these 2 pilots has been in the cockpit for all but 2 of them. Only a very small group of test pilots are qualified to operate the complex machine. Even the lead up to this flight has involved hundreds of hours in the simulator. At 9:19 AM, White Knight 2 takes off from Mojave Air and Spaceport in California, cradling Spaceship 2 between its twin fuselages. The weather is fine, and everything is poised at the ready for the momentous flight.
Alright, rocket motor initialization checks. Ready for intro V?
Ready.
3, 2, 1, mark. Pressure is stable.
Scaled base extra is airborne.
Extra, from Galactic 1, you're loud and clear.
Got you loud and clear, Galactic 01.
Extra from Scat 2-1, loud and clear.
Loud and clear, Scat 2-1.
Taking off behind the Virgin Galactic painted aircraft is an aerobatic Extra 300. It will be flying in loose formation with White Knight 2, carrying a single pilot and a photographer. Public relations has played a key role in the Virgin Galactic business, and documenting this key milestone for all to see will be critical.
This headrest, at least the height I'm at, when I press up against it, I kind of lose the bottom half of the screen.
Right. I remember doing that on PF1. I consciously took my head off the headrest. I show L-10.
Yep.
At 9:58 AM, at an altitude of 46,400 feet, Spaceship 2 is 10 minutes to launch. The pilots commence their L-10 checks. Part of this includes a preliminary check of the feather system.
Right. Feather locks. Here come the locks. And show locked. Backup indications look good. Pre and alt air is coming off. Isolation valve is closed.
All is looking good. The pilots continue to work through the multitude of checks as the extra 300 becomes visual behind the aircraft.
Scat 2-1, this is Mojave Tower. Wind direction estimated 230 at 9er. Approach end of runway 30. Runway 30 cleared to land.
Cleared to land 30. Scat 2-1. L-4 checks are complete.
Alright, you're clear to arm at pylon release. I'll call for fire, and call the pitch up. Pitch down, trim, feather unlock 1.4.
I'll try to keep a hack on that 345 as well.
Okay.
The pilots are briefing their post-release actions one last time. After the spaceship is released, the co-pilot will arm the rocket. Once the pilot commands fire, he'll call the pitch up and down, caused by the bubble as the spacecraft passes the speed of sound. After which, through Mach 1.4, the co-pilot will unlock the feather.
Alright, then after shutdown, roll boost while we have some speed will come off. Primary is coming on, set the attitudes. Feather up at apogee. Reset trims for -10. You're cleared to feather at apogee if I haven't called for it, and remind me to get on the trims if I haven't already got them. Alright, the visibility's going down a little bit here. I still have the lake bed, and
L-30.
The moment which has been months in the planning is about to occur. The pilots move their control sticks forward to ensure clean separation from White Knight 2, and receive clearance from the base to release.
Armed. Yellow light. 5, 4, 3, 2, 1. Release. Clean release.
fire.
Arm. Fire.
Good light.
The strain on the pilots' voices can be heard through the cockpit voice recorder, caused by the massive G-forces they're experiencing as the rocket motor burns.
Yeehaw!
Point 8. Unlocking.
As Spaceship 2 passes just Mach Point 8, we see the co-pilot do something peculiar. He reaches for the feather handle and moves it to the unlocked position. A caution light illuminates in the cockpit.
Pitch up.
Catch up.
All of a sudden, Spaceship 2 violently rips itself apart. The pilot's colleagues in the chase plane look up in horror. Images captured by the Extra 300 show the structure of the spacecraft breaking up from the aft end, essentially folding in half at the hinge point between the wing and the feather flap assembly, before the entire fuselage completely disintegrates. As the main wreckage plunges back towards Earth, the chase plane continues to look up to a sea of debris spreading through the sky. There seems to be no hope that anybody on board would have survived. 3 minutes later though, they see something miraculous. A parachute has been deployed. It's the pilot of Spaceship 2, Pete Seabold. This kicks into gear the emergency procedures designed by Scaled Composites. A helicopter from the National Test Pilot School at Mojave is the first to arrive at the pilot's location at 10:52. On board are a pilot, an EMT, and a flight surgeon. Despite the highly qualified crew, however, the helicopter isn't equipped to transport a patient to hospital. So as soon as an initial assessment is made of Seabold, a request is put out for a Mercy Air Bell 407 helicopter. It takes half an hour to arrive, so first aid is applied in the meantime, readying the pilot of Spaceship 2 for transport to hospital. It's not until an hour and 46 minutes after the accident that the Mercy Air helicopter arrives with Seabold at a local hospital, something which would later concern accident investigators, given the relatively high-risk test flight which had taken place, and the lack of preparedness for an emergency response. It was immediately clear what had happened though. Before Spaceship 2 was supersonic, the Copilot unlocked the feather system. This generated a significant upward force on the feather flap, too great for the 4 flap hinges and 2 feather actuators to counteract, resulting in the in-flight breakup. 2 big questions remained, however. Why did the Copilot unlock the feather too early, and how was he able to? It was the job of the National Transportation Safety Board to answer these questions, but usually only tasked with investigating accidents contained within the Earth's atmosphere, the board took a justification to the US Congress to widen their reach, allowing them to investigate the first commercial space accident. They analysed the Copilot's actions in meticulous detail. Owsbury had memorised his sequence of tasks during the boost phase. We heard it in the final in-flight brief, where he'd call out Mark Point 8, the pitch trim position, and at Mark 1.4 unlock the feather. A fairly basic 3-step sequence. However, what was occurring inside the cockpit was a high workload, high stress environment. The pilots were experiencing acceleration forces of 2.4 to 2.5 Gs, and the vibration levels would have impeded the Copilot's ability to read the primary flight display. Simulated testing showed it was a period of just 16 seconds between the Mark Point 8 callout and Mark 1.4. Just a few moments later, through Mark 1.5, a caution light would illuminate on the multifunction display, before the flight would need to be aborted if the test wasn't complete through Mark 1.8. All of this information would have weighed on the Copilot's mind, as well as the numerous stresses caused by the demanding environment, something which he hadn't experienced while training in the fixed-base simulator. Surely, if there was an effective self-destruct button in the cockpit, there would be a system in place to stop it being actioned at the wrong time. Not a challenge and response protocol for the unlocking, where both pilots would confirm with each other before the unlocking was actioned, nor a design barrier which prevented or locked out the feather handle while the spaceship was in the transonic period, not even a message on the MFD to indicate the appropriate time to unlock the feather. While Scale did have design mitigations in place for some aspects of the feather system, like the procedure to unlock it before Mark 1.8, for others, like the risks associated with unlocking the feather too early, it simply relied on the pilots to do the right thing. In all, it seemed that much of the efforts at Scale were focused on the reliability of the feather itself, rather than the design of a robust system to minimize the possibility of human error. Scale did no consultation with human factors experts, and the NTSB found a lack of emphasis on human factors in their simulator training, where pilots didn't train with the same flight suits, helmets, and other equipment they required in the plane. In the end, the NTSB made 17 findings. It recommended that human factors be brought to the forefront of experimental permit applications. and urged for clearer policies and guidance on the fledgling commercial space industry. Despite serious injuries, Pete Seabold would go on to survive. His ejection seat had never actually deployed. Rather, the investigation revealed that he was thrown out of the cockpit as the fuselage broke apart, blacking out after separating himself from his seat, before awakening to his parachute automatically deploying at a lower altitude. Michael Lounsbury's fate was not so lucky. His body was found with the main wreckage, strapped to his seat inside the cockpit. Virgin Galactic resumed its test flight program in September 2016, with a new Spaceship 2 prototype named VSS Unity. The updated version now contained a mechanical pin which would prevent the unlocking of the feather during unsafe stages of flight. Then on July 11th, 2021, conveniently 1 week before a planned spaceflight by Jeff Bezos, Richard Branson and 3 other Virgin Galactic staff became the first passengers to reach the heights of space in VSS Unity.
To the next generation of dreamers, if we can do this, just imagine what you can do.